Are you ready for another rule? So we've, at this point, learned our power rule. We've talked about our product rule. If we have a product rule, we probably have a quotient rule, don't we? Oh, yes, we do. So today, quotient rule. It's used to find the derivative of a rational function, or if we divide two rational functions, I guess I should say. So, what does that derivative look like? If h of x is f of x divided by g of x, h prime of x is going to equal the denominator multiplied by the derivative of the numerator, subtracted by the numerator times the derivative of the denominator, all over the denominator squared. Oh, good gracious. How do we remember that? So if you recall from product rule, I gave you 1d2 plus 2d1. Here we also have a little bit of a saying that we go along with it. I cannot take credit for it. It comes from my calculus teacher in high school. I'm not sure where he got it from, but I've seen many people using it. If you search the internet for quotient rule songs and whatever rhymes, you could get a slew of them, and a lot of people do a little bit of their version of this. So here's what we got. Basically, low d high, less high d low. Draw a line, denominator squared we go. So a little bit of a tune there. If I was in class with you, we would go ahead and sing this several times, and we make fun of each other because we're all not very good singers, are we? So anyway, here we go. So what does this mean? So low is our denominator. So it's the bottom part, low. D high, D means derivative, so we're going to take the derivative of the high, derivative of the numerator. Less, minus, high d low. So we take the numerator times the derivative of the denominator. We draw the line, so we make the fraction, and we denominator squared we go. So we take the denominator and we're going to square it. So again, I like this. I use it as I find the derivative of many quotients. It's just something that has stuck into my head, and it's the way I do my derivatives when I do quotient rule. So it depends on how your mind works. Do you like rules? Can you remember g of x times f prime of x minus f of x times g prime of x all over g of x squared? Some of you probably can. Photogenic memories. Others of you kind of like the jingle. Low d high, less high d low. Draw a line, denominator squared we go. That's the way I kind of like to think of it. Either way, let's go ahead and look at example number 1. Here we have h of x equals x plus 1 over x minus 2. So what does that derivative look like? So to find the derivative of a rational, I'm going to take the low. I'm going to take my x minus 2, my denominator. I'm going to multiply by the derivative of the numerator. From that, I'm going to subtract the numerator and times the derivative of the denominator. And it's divided by the denominator squared. Please, 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 please do not cancel any terms that are not in all of the different parts of the rational expression. Some of you are going to cancel the x minus 2, and I'm going to mark it wrong because I told you, do not cancel pieces. You have to clean up the numerator first. So we will eventually see where we have x minus 2's that are canceled, but in this example, we're taking x minus 2 times 1, and then from that we're subtracting x plus 1 times 1. So the x minus 2 is embedded within a bigger part of that numerator. Multiply my 1's through, I get x minus 2. Distribute the negative. If you're going to make a mistake, 1, you're going to just cancel those out, or 2, you're not going to distribute that negative all the way through. That's over x minus 2 squared. Clean that up just a little bit more. Our x's are going to cancel, so we get negative 3 over x minus 2 squared, and that's going to be our h prime of x. In example 2, we have the 2x plus 5 over 3x plus 1, so we see very similar to example 1, but we have now some coefficients. So how do we see that playing in? So our derivative, again, we have low d high, derivative of 2x plus 5, that's 2, isn't it? So see, we don't necessarily have that 1 at this point in time. Less high, 2x plus 5, d low, 3, and we're going to divide that by the denominator squared we go. Again, cannot cancel out that 3x plus 1. It's not The numerator doesn't have 3x plus 1 in both of our terms. But we can distribute the 2. So we get 6x plus 2. We can distribute the 3 and the negative. So we get a minus 6x minus 15. If you wish, you could do that in 2 different parts. It's quite up to you, as long as we end up with the same answer at the end. The 6x's are going to cancel. 2 minus 15 gives us negative 13 over 3x plus 1 squared. And that gives us our derivative, or h prime of x. Hopefully, you see that these are very similar to those problems that we began when we did our verification of rational expressions, the very first couple sections of the year. And again, example 3 and 4 here, not going to spend a whole lot of time. They're not a whole lot different, so if you don't want to spend a lot of time looking at them, we're just going to change that first term within our terms. So we have low x minus 3, derivative of x squared plus 5. We get 2x minus high x squared plus 5. Derivative of the top, or bottom, sorry, derivative of the denominator is 1 over x minus 3 squared. Cleaning this up, we get 2x squared minus 6x minus x squared minus 5. And that's over our x minus 3 squared. Cleaning that up, we end up with an x squared minus 6x minus 5 over x minus 3 squared. And some of you are probably saying, well, how do I know when I'm done? Well, can we do anything with that numerator, that x squared minus 6x minus 5? It looks factorable, doesn't it? But if we look at it a little closer, we can't multiply two numbers to get a negative 5, which is prime, to get a negative 6. If it was a plus 5, we could, but that's nonetheless not going to help us, is it? So we're going to leave it like that because there's nothing else we can do with it. And our last example here, example 4. So we have 2x to the third minus 1. Oh, sorry. Whoa, I didn't sing my song. Low, x squared plus 4. D high, 6x squared less high. D low, 2x all over x squared plus 4 squared. So see, it's even easy for me to start off incorrectly if I'm not singing that little tune in my mind. Just kind of keeps you on track. Multiply your 6x squared through, we get 6x to the fourth plus 24x squared minus, remember, multiply the negative through and the 2x, so we get a negative 4x to the fourth. This time we're going to plus, negative times a negative 1 is positive 1 times 2x gives us a 2x. And that's over x squared plus 4 to the second. Cleaning that up, we get 2x to the fourth plus 24x squared plus 2x divided by x squared plus 4 squared. If you want, you could take out a 2x there. I'm not going to say yes, I'm not going to say no. What we're ultimately looking for is, will there be a factor up here that will cancel with the denominator or part of the denominator? And as we're going to do a few of these, in this case, it rarely happens. In this case, it's also not going to happen there. We're not going to factor an x to the third trinomial into anything for us to help to get rid of that x squared plus 4. So we're going to leave the answer just like that. So again, we could leave either one of these as our answer. I am going to ask you to get to one of those two, or the answer that's posted online or in the back of your book. So good luck with the quotient rule today.